Swayam Prabha. Digital India. Educated India.
Once again, let me continue to compressibility of soil. Till the last lecture, what I have various aspects of compressibility I was discussing, and I have discussed normally consolidated soil. And now I will take another, actually, since normally consolidated is there, so it will be over consolidated also will be there. So, I will see what is over consolidated soil. This is how will be, what is the over consolidated soil and how will be the compression curve of over consolidated clay. And let me first define what is the over consolidated clay. An over consolidated clay is one which has been subjected to a pre-consolidation pressure in excess of its existing overburden. That means, suppose at a particular depth at any point or at any point, suppose at even close to surface there is some overburden pressure, but if you look back and see the entire history of this deposit, and you may find that this layer was subjected to a higher pressure than the present overburden pressure, that is called overburden pressure. How it happens actually? Suppose this soil was initially this much thick, and under this loading, suppose this soil is consolidated, and because of some construction issues etc., maybe this much soil is removed, and maybe several years back, and this much soil removed, then that means at present condition this soil at this point will not have the highest pressure it has been subjected to before, it will be much lower. So, that is what an over consolidation clay is one which has been subjected to a pre-consolidation pressure in excess of its existing overburden pressure. That is the example, actually, because of some reason soil may be removed, eroded, and then overburden pressure is released. That means, before that the soil is compressed by a higher pressure, and the resulting compression being much less than for a normally that means, if it is a pre-consolidated soil, that means already it was consolidated, then now if I calculate apply certain amount of load, then compression is expected to be much lower than the normally consolidated soil. So, the semi-log plot is no longer a straight line. That means, if I now over consolidated soil, that means if I calculate E versus P, and then finally if you plot E versus log P, then it will not be a straight line. It will be in fact it will be continuously a curve, but we can divide it into two straight line for convenient of calculation or analysis, that I will show you in the next slide. And from the EP curve, it is possible to determine an approximate value for the pre-consolidated pressure. So, EP curve actually if you plot, I will show in the next slide there. It is important to find out pre-consolidation pressure. That means, in any calculation to estimate the total consolidation settlement, you need to know what was the if it is a over consolidated soil, you need to estimate what was the over consolidation pressure. So, there is a graphical method given by Krasnagande, and in that actually using the EP curve, you have to first estimate the point of greatest curvature on the curve, that I will show in the next slide. It is like that. If you do EP curve, E log P curve, it will be something like this. So, you have to find out point of greatest curvature, that is the point A, suppose. Then from there you have to draw a horizontal line, and then a tangent, you have to draw on tangent, and then you have to bisect the angle B, that means this angle you have to bisect, and then from this the original straight portion of the curve to be extended to intersect this bisector. At that point actually will be your pre-consolidation, that I will show in the next slide also. And this is the actually there is no theoretical backing for this. In fact, people in the past what they have done, they have conducted several tests and they have plotted and tried to find out different ways, and finally they got this is the generalized method by which if you do you get approximately a pre-consolidation pressure. This is just this is totally graphical method, there is no theoretical basis, based on observation only and practice people developed this method, and this method is still working quite well. And so, let me go to next slide, and in a better clean figure let me show. So, this is the one actually we can show you. This is the log E versus log pressure curve is this, suppose this one, and then the point of greatest curvature, suppose you have to find out. So, this is the point, and from there you supposed to draw horizontal, this is horizontal, and from this point this is tangent, and then you have got an angle BAC, and this is bisector, this is actually bisector. And then once you got this bisector and this curve is continuously curved, and but towards the end it becomes straight. This original, this straight portion of the curve, if you extend and meeting the bisector. So, this is extended, this is extended to bisect or intersect the bisector, and that point actually if you drop on the x axis, the value red will be your pre-consolidation pressure. So, now this is the graphical method, and laboratory from the test data you can find out this, but when it is a field compression field test, sometime we can do or actual pre-consolidated pressure for the field content, that there is a field method is there. I am not discussing this one, I am keeping because maybe undergraduate level may not be required. So, I am just keeping away this one. Field determination of corrected compression curve, that is correct because of the sampling and testing in the laboratory, this is actually not the actual virgin consolidation curve. So, because of that there is some correction, I am not discussing that, I will just concentrate only if you know the EP curve, from there how to find out the pre-consolidation pressure, that is the method I just want to mention here. So, this is the method, that what is the method? If you have E versus pressure, E versus log pressure curve, find out the point of greatest curvature, draw a horizontal, draw a tangent from those points, and then the angle we get because of this drawing by drawing these two lines at point A, you divide that bisect that one by a line, and then the straight portion of the E log P curve you extend back to intersect the bisector, and that point, from that intersecting point you vertically drop to the x axis, that will log pressure axis, and then it will intersect the x axis, that at point you read the value of pressure, that become the pre-consolidation pressure. And for most of the practical case, suppose if you have a E log P curve for practical purpose, suppose this is the curve and if this is the pre-consolidation pressure, we generally consider two straight line, this is one straight line, this is one straight line. So, this is recompression curve and this is normally consolidated curve. So, these two part actually you will use while doing calculation. So, that I will show you in the next few slide. And you can see now observing this E versus log P curve, this is a straight line, and then you can utilize that to find out the compression. We have already developed or we have shown one calculation for how to find out the total consolidation settlement. Delta will be equal to mv multiplied by del P multiplied by H. This way, that is called mv method. So, you can calculate the settlement. So, if there is a 10 meter thick layer and because of construction of foundation, there will be increase of pressure on the soil, and because of this increase of the pressure on the soil, what will be the total consolidation, that can be estimated by using this equation. How? This equation will be first to be MV to be estimated based on E versus pressure plot, and del P, that means if you have a clay, if you have a soil, and on that if you construct a foundation, from the foundation at the middle of the clay layer how much pressure is transferred, that to be calculated. That is actually already you have discussed, that Bouzin's method, trapezoidal method, many other methods we have discussed. That means if you apply a load through a footing like this, and suppose clay layer is somewhere here and this much thickness. So, because of the loading here, what is the pressure at this point? So, that to be found out by using Bouzin's and many other methods we have discussed already. You can see go back and see that. So, that means by that way one can find out the consolidation settlement MV method, and there is another method where that is called log method. So, we have already observed that E versus pressure plot data, if you plot in a semi log plot, that means pressure is in a log scale and E is the natural scale, then we have seen that except the initial portion the curve is a straight line. So, if you do that and if you recollect whatever we have learned before, that dH by d1, we have shown dH by d1 is nothing but dE by V. This is original volume and this is delta E by, that means volumetric change. This is a volumetric change, one way definition. This is another way of defining volumetric change. So, this will be equal. So, if you consider that, then dH will be equal to E1 minus E2 into H1 by 1 plus E1. And now, so if I want to find out the delta, that means integral of dH, that means if I have the E log P curve like this. So, from here to here I have to integrate. So, integrate if I do, integration if I do, then ultimately you can see dH equal to, this is nothing but E1 minus E2. So, this is E1 and this is E2 and this is P1 and this is P2. So, E1 minus E2, from this line I can write Cc into log P2 by P1. Okay. So, this E1 minus E2 is nothing but Cc into log P2 by P1. So, if you substitute that one, then you are getting a equation Cc into H1 by 1 plus E1 log P2 by P1. This here actually log, so when you plot a semi log plot, that log actually 10 base log. So, this will be 10 base log 10 base P2 by P1. So, this is one formula, that is called log formula, to find out the total consolidation settlement. Suppose this is the same one, if I consider this is the foundation and it is applying some load on the soil, and suppose consolidating layer is here. So, because of this load, what is the pressure here you have to find out. So, you can see Cc into H, Cc means compression slope of this line, Cc is the slope of this line, then only I can write this one in this form. So, E1 minus B2 equal to Cc into this from here only it is coming. So, the Cc is the slope of this line and it is known as compression index, and another thing is, so Cc will be obtained from this graph, H is known, what is the thickness, one initial void ratio is known. So, what is required actually P2 by P1. What is P2 and what is P1? P1 is before applying this, before constructing this foundation, what was the effective overburden pressure at this level, that become P1 before construction of foundation, effective overburden pressure, which will be equal to P1. And what is P2? P2 is P1 plus pressure increase due to foundation loading. Foundation loading, and of course, you have to find out at the middle of the clay layer. So, there are 2-3 ways one can do. Directly one can find out the pressure increase here, or one can find out pressure increase here and pressure increase here, average of this can be obtained, or and that can be obtained by Boussinesq or by trapezoidal distribution. All those things I will discuss later on. For the time being, we have to understand this meaning of this equation. Total settlement of a particular layer because of this loading will be equal to C c into H by 1 plus E log P 2 by P 1. What is C c? If I collect a sample from there and if I do a test in the laboratory, and then E versus pressure, if I plot in a semi-log curve, then you will get a straight line. The slope of the straight line will be C c, that is obtained from the laboratory. Of course, to find out the C c, there are many methods available, empirical method. People actually conducted test on different types of soil and finally correlate with liquid limit, plastic limit, and many other things. There are many equations are available, but otherwise those are applicable sometimes in particular soil. Otherwise, you can sample it, do the test, then E versus P data generate, then from there you plot E versus log P, and from the slope of this you get the value of C c. So, C c is obtained, and E naught also initial void ratio to be obtained, and then log P 2 by P 1. So, to find out P 2 and P 1, P 1 is actually before applying any load, what was the originally effective overburden pressure at the middle of the clay layer. So, that is just weight of the soil above this, weight of the soil above this. If I are considering this point, so weight of the soil above this to be considered as effective overburden pressure. And obviously, if there is a water table, then you have to subtract pore water pressure. That method we have discussed many times. So, once again obviously we will repeat same, otherwise if I do again and again only you will remember, otherwise there is a chance of forgetting or doing mistake. So, again while doing problem I will again this type of thing I will take saturated or with water table, so that how to find out effective overburden pressure, that I will show you again. And that is effective overburden pressure before application of the or applying the load is P 1, and once load is applied through the foundation, then what is the increase in pressure in the middle of the clay layer, that can be obtained by different methods. Boussinesq method can be used, corner formula can be used, which is nothing but Boussinesq formula, of course some way we are using Boussinesq formula, or approximate method. That means if I draw if I construct a foundation and apply load, and we can visualize that when you go deeper and deeper the load will be dispersed. So, that dispersion 2:1 to be considered, and by you can assume that the trapezoidal distribution, and by that the width of the foundation is increasing, you are going deeper and deeper. By that how to find out the pressure we have discussed, and I will show you once again. So, that means there are several ways to find out del P, or so P 2 is nothing but P 1 plus pressure increase due to loading, and this is typically we can say del P actually. So, because of the foundation whatever load is coming, that is del P. So, P 1 to be calculated, del P to be calculated. So, P 2 will be P 1 plus del P. Once you know all those things, you can calculate the total consolidation settlement. So, now let me see one problem, very simple problem. The problem will never be so simple, but to illustrate the formula I will just take this problem, and you can see. So, before going to that problem, let me, as I have mentioned that C c is the slope of the E log P curve, but I have mentioned that there are several methods available to find out C c. One such method is given by Terzaghi. Actually, C c equal to 0.009 into liquid limit minus 10. So, liquid limit is written sometime this we use sometime for water, we use for water content. So, when you use with L, that means it is liquid limit, otherwise liquid limit also sometimes LL. So, different ways people write. So, either you write this or this, it is nothing but liquid limit. So, 0.009 liquid limit minus 10. So, by this actually you can find out also compression index. Suppose a particular soil is having liquid limit equal to 45. So, your CC will become 0.009 45 minus 10. So, it is 0.009 into 35. So, whatever value it comes, that is your CC. So, this is a very approximate, generally you get a very conservative side, but it is generally recommended that when you practice, you have to collect the sample, do the test, plot it, and then from there you get the value of CC. As I have mentioned that very to illustrate the problem equation what we have used, there is a simple problem we have taken here. You can see the problem is soft normally consolidated clay is 15 millimeter thick with a natural moisture content of 45%. The clay has saturated unit weight of this, a particle specific gravity 2.68 and a liquid limit of this is 65%. A foundation will subject the middle of the clay layer to a vertical stress increase of 10 kN/min. So, generally this is never be given, but here it is given. Suppose you have a foundation, this is the foundation and some amount of load applied through this and clay layer is here. The middle of the clay layer, what is the pressure because of this foundation load, you need to calculate, but here actually it is given that a foundation will subject the middle of the clay layer to a vertical stress increase of 10 kN/min. Because of this foundation, del P is 10 kilonewton per meter square, that is given. So, part of the calculation is not you do not have to do, otherwise in actual practice problem or actual problem you generally have to find out first del P and P2 P1 and then find out P2. So, this is given. So, calculation is reduced. So, determine the approximate value of the consolidation settlement of the foundation if the groundwater table is at the ground level. So, this is another point is given. So, that means your groundwater is here. Okay. So, based on that let us see the calculation. So, the clay layer thickness was something 15 meter. So, 15 meter thick layer and water table is here, and so you can see the because of this foundation at the middle actually del P is given, but what you have to find out P1, P1 is nothing but effective overburden pressure. Okay. So, effective overburden pressure. So, so you can see initial vertical stress at the middle of the clay layer will be how much. So, unit weight is given 17.2. So, since it is water table underwater, so your effective unit weight will be 17.2 minus 9.81 into middle of the clay layer. So, into 7.5. So, that become 55.4 kilonewton per meter square. But so, this is effective overburden pressure and the final effective vertical stress will be, that is this is P2, this is actually nothing but equal to P1 and this is actually P2. P2 will be this effective P1 plus this is delta P. So, 65 and initial void ratio was W1 equal to that we know since it is saturated, that can be obtained W into G. W is the natural water content, G is the specific gravity. So, from there I get 1.21 was the initial void ratio. Then CC again 65% is liquid limit is given, liquid limit is 65%. So, 0.009 into 65 minus 10 in that is gives you 0.495 as the CC. So, that means your CC into H 1 plus E1 log P2 by P1 or P1 plus delta P. That is also sometime we write P1 plus delta P by P1, and if you do this you will get a settlement of 240 millimeter for this. Now, I will show if it is a over consolidated clay, how to find out the consolidation settlement. And you can see that as I have mentioned before that E versus log P curve, we generally take this way. This is E and this is log P, and this is CR and this is CC. This is actually pre-consolidation pressure. This is the way we take, and now actually we are using little different symbol, otherwise it is same, everything is same. This is initial effective pressure, this is nothing but P1 and this is delta sigma. So, initial effective pressure is suppose somewhere here, initial effective pressure is somewhere here, and you have applied delta P in such a way, it is delta P you have applied this much. Then the consolidation is only in this, within this curve, along this only. So, if I want to find out the consolidation pressure settlement because of this loading, then what will happen? Slope of this curve is the CR. CR is actually recompression, coefficient of curvature for recompression. CR actually coefficient of curvature or compression index for recompression. Okay. So, it is over consolidation settled soil, this portion is recompression. So, compression index for recompression. So, that means it is still it is recompression zone. So, your formula will not change. So, CR into H, instead of CC you will be using CR into H 1 plus E naught corresponding to this Void ratio is E naught log, this is suppose P1 and this is our delta P and this is P1. So, same formula to be used, only instead of CC it will be CR and P1 to be calculated and P delta sigma to be calculated. So, this formula for over consolidated, though the soil is over consolidated, but during construction if you load in such a way that your present effective overburden pressure per delta sigma does not increase or exceed the over consolidation pressure, this is much below the over consolidation pressure. In that case your compression will be much smaller. So, you before that pre consolidation pressure. So, this is the formula to be used, and if it is delta P is applied in such a way that suppose delta P is here, okay, then your delta P is in this range, because of this to this is delta P. Then the soil is compressing from here to here by some way and from here to here another way. So, there are two parts, there will be recompression and there will be a compression part. So, from here to here, from 0 to or initial effective pressure to pre-consolidation pressure, that is recompression, and for pre-consolidation pressure to next level of pressure, that is actually compression. So, if I see this one, next slide, let me see, and you can see this one. Suppose this is the curve is something like this and your P naught is somewhere here and delta P is this, this is delta P. So, what I will do, I will calculate for this and calculate for this. So, for calculation for this I can see this is recompression. So, CR into H 1 plus E log, here it was sigma naught and here actually this is actually nothing but delta sigma minus this is original effective pressure here. So, this is actually delta, so delta sigma naught plus this. So, what I will do, the you know the pre-consolidation pressure at this point. So, pre-consolidation pressure minus initial pressure, that is delta pressure. pre-consolidation pressure minus this will be the delta pressure. So, sigma naught plus this by this, and if I simplify, shear into H by 1 plus E log ultimately sigma Pc, that this is sigma Pc is nothing but pre-consolidation pressure by sigma naught. Now, to find out this portion from here to here, you can see, since it is compression is the actually compression, virgin compression. So, it will be Cc to be used, Cc into H 1 plus E naught log, and here actually starting compression is sigma Pc, and delta sigma will be how much, this to this. So, from here to here, how to find out? I can find out P naught plus delta sigma, P naught plus delta sigma, that I am reaching up to this, P naught plus delta sigma, that I am reaching here. Now, already I have taken the effect up to this, then I have to subtract the sigma Pc. So, you can see sigma naught plus delta sigma minus sigma pre-consolidation. So, that means I will get this portion separately, this portion is for this portion is this, and for this portion is this, and if I simplify this, Cc into H by 1 plus E sigma naught plus del sigma by sigma pre-consolidation. So, it will be having two parts, one is because of the recompression and one will be the normal compression, these two parts to be calculated separately if it is over consolidation pressure, and shear value will be much smaller than the Cc. If not given or not estimated, then it is approximately 1/5 of the Cc can be taken as value for calculation. And so, that means if it is over consolidated soil, to find out the consolidation settlement, two ways you have to see, after the application of the delta sigma, you have to see whether you are crossing pre-consolidation pressure or not. If it is not crossing, then only shear portion to be applied and normally consolidated equation to be used, and if your application of delta sigma is cross the pre-consolidation pressure, then it will be having two segment, one is for recompression, another is a compression. These two together will be the total consolidation of the soil for the over consolidated soil. So, this much actually I wanted to cover here. Next class I will take some application of this problem, etc., and further rate of consolidation, etc., I will take subsequently. Thank you. I will stop here.